All right, mathletes, word on the street is you want to graph these parabolas in vertex form. I'm your man. All right, let's dive into this. Let's make it short, sweet, and easy. All right, so first of all, here's when it tells you a form, make sure you know that form. Write it down until you have it in there, right? That's when you stop writing it. Okay, so vertex form, first of all, here it is. What does it mean? Well, this A value here that you see here, this is going to control if it's positive, right? If it's bigger than 0, your graph's going to open up upward, right? If A is negative, right? If A is below 0, your graph is going to open up downwards. A can never be 0, or else this would not be a parabola, all right? So write that down. Look at your formula. It says x minus h. So see how it has that minus h? What we know here is we could, since this is in vertex form, we could get the vertex from here. So the vertex is going to be h comma k. But what I want to let you know is, see that minus? Whatever h they give you, you're going to take the opposite sign. So it's going to be the opposite of the number you see here. Look at this example. See how it's plus 2? That means your h is going to be negative 2. So always remember that. All right, so when we're graphing these, just remember, this is a parabola. A lot of people, you read a lot of notes out there and they're telling you there are 200 steps of how to graph these parabolas. Let's make this easy to think about. What am I interested in? If I see a parabola, what am I interested in? Number one, I want to know that maximum, that peak, that vertex. It might be a maximum or it might be a minimum, depending on how it's facing. I'm going to need to know these x-intercepts, right? That'll be pretty darn helpful. So I'm going to find x-intercepts. What else do I need to know? Probably this y-intercept. That's going to be pretty helpful. And again, with those pieces of information, you have your graph. Sometimes you might have to plug in a number because it might not have an x-intercept. So you might need a few more points to plug in, but that's easy. All right, so let's dive in here, folks. So we have this function and we want to graph this. So first things first, let's find its vertex. So the vertex we just said is the opposite of h, so the opposite of this guy, so it's negative 2, and this value, you keep it the same. All right, so it's negative 2, negative 1. All right, that took a couple seconds. Next thing we're going to do is let's find those x-intercepts. Maybe they have them, maybe they don't. Let's find out. So whenever you find the x-intercepts, don't forget everything you already know from the past, right? So x-intercepts, that just means we're going to set y, which in this case is g of x, set that equal to 0. So we set everything equal to 0. Don't plug 0 in, set it equal to 0. So you get 0 equals x plus 2 squared minus 1. Now we solve this. What's awesome about vertex form, man, it makes things so much easier to solve. So we're going to go ahead and add 1, right? Because my goal first is to get this by itself. So I'm going to add 1 to both sides because I want to isolate that x eventually. So we get 1 equals x plus 2 squared. Now I'm going to take the square root of both sides, right? Because I want to get rid of that square. So just remember, when you take that square root, you're going to end up with two answers, a plus and a minus. All right, so we take the square root of both sides. So we have x plus 2 equals plus or minus 1. So we're going to have two possible outcomes, two equations here. So one equation, let me write it up here for you all. So my days of Kentucky, living in Kentucky for 7 years, coming back, how y'all doing? Negative 1 equals x plus 2. I'm going to subtract 2 from both sides. So I get x equals negative 3. There's one of my possibilities. Or, right, we have our other equation which says 1 equals x plus 2. Subtract 2 from both sides and you get x equals negative 1. So those are our x-intercepts. Those are the x-intercepts. And now the last thing, let's go ahead and find the y-intercept. The y-intercept. So when we go and find the y-intercept, remember what we're doing. We're going to let x equals 0. All right. So we're going to find g of 0. And so that equals 0 plus 2 squared minus 1. So we end up with 2 squared minus 1, and we end up with 4 minus 1 equals 3. So we end up with the y-intercept of 0, 3. Now we have everything that we need to sketch the graph here. So if I were to do a little etch-a-sketch here, as I call it, of this function. So let me draw a little sketch here. I got -2, -1. There's my vertex. Bam. My y-intercept was 0, 3, 1, 2, 3. Right there. My x-intercepts are -3, -1, right there and right there. Let me make them different color so we could actually see all these points. Here, 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 and here. And we know it's parabolic. Please don't make it look like a V. This is like a parabola, right? Nice and smooth. I'm gonna draw as smooth as possible. And there you have it, folks. So then once you have this shape here, we could start to answer more questions. What's the domain? Well, how far left and how far right does it go? Dr. Math has videos on all that stuff. So domain, -infinity to infinity. What's the range? How low does it go? Well, the lowest point we saw was -1, right? That was the lowest. So -1, how high is it going? All the way to infinity. So you can start to answer all these questions once you have the shape. And I'm not going to lie to you, right? Because I'm watching these other videos and they're like, oh, the fastest way to graph parabolas in Vertex Form. What they do is they do a Mickey Mouse problem for you like this, right? So this is an easy example, because once you go beast mode, right? I'm not going to lie to you here. These problems become a little bit more complicated, right? If you want to see those, man, smash that like button, subscribe, because what's going to happen is this, right? I'm not going to lie to you. When you find your x-intercepts, sometimes you don't have x-intercepts, right? Sometimes this equation isn't as easy to solve. Maybe this is in standard form and you have to use a quadratic formula, right? So there's all these other techniques that come into play. But the beauty of this is the process stays the same. Sometimes you just need additional tools. So if you want to see some harder problems, let us know. And here in Dr. Math Studios, we have your back. I'll talk to you in our next video. Peace.